In part one, we took a look at the terms and technology and the magic that makes wireless all possible. And in this nugget, we're going to focus on two things. Number one, we're going to plan out the network for wireless, and then we'll walk through step by step configuring it. Let's jump in. So our goal in this second half of the nugget on wireless, it's really simple. One, we want to plan the network. And number two, we want to configure the network, the wireless network. That's it. So as far as planning goes, here's some things that you and let's give ourselves a scenario. So let's say that somebody calls us both over to their home. Hey, come on over, have a look at my house. It's brand new. We go over and visit them, and they say, oh, by the way, I've got this wireless router in a box, but I'm not sure exactly how to set it up and get it going. Can you help me? What do we say? We say absolutely yes. We love to play with the hardware and configure it. So as far as planning goes, we would need to plan on a few things. Number one, we need to plan on this cloud called the internet. So if the user wants to get to the internet, we need to have some type of connectivity there. So let's say that he says, oh, I've got a cable modem. I've got a coax cable coming in from a service provider to my home. So we'll draw a home here. There's his home. And he's got up in his office of his house, he has the cable coming in, and there's a cable modem, CM. So what the cable modem does is simply takes the signals appropriate from what the service provider is sending back and forth, and it can understand them. So it's like the middleman between your home and the cable modem network from the service provider. From that cable modem, we have a Ethernet connection. So when we talk about Ethernet, we're taking a look at just copper, unshielded twisted pair cable. So there's a RJ45 connector here on the cable modem, and we connect that through a patch cable over to a router. Now this is how most people are going to do it. We could just put a PC right here, but most people are going to use a router. Now that router that we actually purchase at like a electronics store, that router has several components. One is if it's a wireless router, it's got a router built into it. Let's make a list here. And as a reminder, routers work at layer 3 of the OSI reference model, and they make forwarding decisions based on layer 3 addresses. This router also has a built-in, probably a 4-port switch. So it has probably a 4-port switch built in. That would be layer 2, also built in. And it has probably 4 of those and 1 port that goes out to the internet. So these go in. You could have your PCs here all hardwired if you wanted to. And very likely this wireless router also has built into it an access point. So an access point is nothing but a radio transmitter for sending and receiving bits, and most home routers have them built in. So this is a wireless router. It's operating at layer 2 and layer 3. It's also able to support wireless. So with wireless, it's sending the signals back and forth. So we're at our friend's house, getting back on our story. He asks us if we can configure it. We say, oh, great. Do you have your connection to the internet? Is your cable modem currently physically connected? And we take the connection off the router, which is this guy right here, and it'll be labeled this. It'll say WAN. Kind of funny because it's an Ethernet port, but it's labeled WAN on this router right here, and that's the one we plug to the cable modem. So the WAN goes to the cable modem, and the cable modem goes out to the internet. If you're using DSL, which is a digital subscriber line, where it comes in instead of on coax cable, it's coming in on unshielded twisted pair, like what looks like the old normal phone lines. This wouldn't be a cable modem. It'd be an adapter for the DSL, but the router part would work the same. So we make sure the physical connections are there, and then we look at this router and we say, now what do we do? Well, the first thing to do before we do anything else is to plan. And planning involves a couple things. We want to find out what SSIDs and what channels are currently in use. Well, Keith, nothing's in use. It's his house. He has a brand new router. Nothing's in use. Well, the reality is he's got neighbors. And in a corporate environment where you have an office building, there's tenants that are next to you or on different floors. So the very first thing we want to do is a site survey to find out what else is out there so we can plan around it. So if it's just a single router, a single access point, we can choose an SSID that we want to use, and then we can also choose a channel. And we can choose a channel from the 2.4 if we're dealing with that kind of a wireless router, or we can deal with something out of the 5 gigahertz range. It's completely up to us based on what our hardware supports. If it only supports 2.4, you're going to be stuck with 2.4, and that's it. So we can choose our SSID, choose the channel we want to use, and many of the routers the wireless routers will automatically, I call it automatically, figure out what is currently in use, and they'll try to choose something that's free. But we want to plan it out, and then we'll go ahead and configure it. If I was in a corporate environment, and let's say we had that building from our previous nugget, and we had dozens of offices, and I needed to put in 3 access points here, here, and here. I want to make sure that the SSID was the same on all of them. In fact, let's just break out a little bigger picture of that so I can make sure it's clear. So here's our office that we need to cover, and let's say I need to use several access points to do it. So access point 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a really large area that I need to cover, and I'm using 9 access points to do it. Now hopefully we have a wireless LAN controller we can just have all these access points report to. But if we had to do it manually, how do we make sure we do it right? Well, as far as the planning goes, we would want to make sure that all of them were advertising the same SSID, and that would be the extended SSID information. So they're all advertising, for example, Acme Inc. wireless LAN, or whatever you want them to advertise as the SSID. And now as far as frequencies go, they cannot all use the same frequency because they would run into each other. So how might we do that if we had to do it manually? Well, a couple guidelines for planning is that if we want the user, so here's the happy PC, it's a laptop that's going to be walking around maybe, we want him to have full coverage everywhere. So we're going to want to have coverage at least like 15% overlap as far as the actual range of the access point. Not the frequency overlap, but the range of where they cover. So in case in point, access point 1 might cover this, and access point 2 might cover this, and access point 3 might cover this range, and 6 might do this, 5, 4, and then 7, 8, and 9. So there's some overlap. Now how much overlap can there be? There can be more than 15%, but a good guideline is 15% overlapping coverage. That way the roaming user, as he walks around with his PDA or what have you, as he goes from one zone or one cell to the next, he's got complete coverage. So how do we handle the frequencies? Well, if we had to do this ourselves manually, we weren't using a wireless LAN controller, we could do something like this. We could use channel 1 here. And do you remember the 3 different non-overlapping channels we can choose in 2.4 gigahertz range, that band? It's 1, 6, and 11. So by doing that, we can say, well, we use 1 here, and let's use 6 here, and we could use 11 here, and check it out. None of those are going to harm each other. We have overlapping coverage, but we're not running into each other. And then over here, we could use 6, and you'll notice that this 6 right here doesn't actually overlap with this cell or this cell. And then down here we could go 11, and basically it's going ring around the rosy. So 6 and 11 and 6 and 11. And if we look at that, we should have none overlapping. So 1 is the hub. You could use 11 as the hub or 6 as the hub. It doesn't matter. And then you rotate the other 2 non-overlapping channels all the way around it. So this is an example of an extended service set with 15% overlapping in coverage and 0 overlapping in frequencies. So this is a happy network. And fortunately, it worked out like that. You may have a network where it's not going to come out cleanly, so you may have to adjust. Maybe you have to put a couple extra access points in. Even though you didn't need the coverage, you need to do it so that you could actually have non-overlapping channels. And then you can adjust the radio power. So the radios on the access points, spell that right, radios, you can adjust. So you can say you want them at full power, or you want them at 90% or 80% for a couple reasons. 1, so they don't bleed too far over into another area that might be using the same channel, and also because maybe you don't want this access point broadcasting all the way to the parking lot. That might be another cause for maybe getting some unidirectional antenna that send traffic only this way, but not in all directions. Okay, so that's our planning phase. So let's do this. I've got access here to our network. We're going to do a site survey, you and I, right now, so we can help our friend put his access point, his wireless router, into motion. Let's do that right now. So let's do a site survey for our friends. So we whip out our laptop, and let's say our laptop has a wireless adapter, and we run a little application. This is an example of one of those many applications you can do this with. It's called NSSIDER. I love the name. It has the SSID in uppercase, so it's Insider is the name of the program, but it's looking at SSIDs, the service set identifiers. So it basically is going to show you everything that my computer is currently aware of. Now you can sort based on SSID alphabetically by the channel that's being used, the RSSI, which is the received signal strength indication. And if we take a look at these, sort by that, the lower the number, the better the signal. So I'm most, no wonders, the strongest signal that's coming in right now is from a wireless device, an access point, a wireless router that has the SSID of Barker. It has the channels that are currently in use, and it has the type of security in use, the MAC address, the layer 2 address of that wireless device, the max rate, the vendor, and what type of network it is. So you know what this is, friends? This is the opportunity for you and me to review all those concepts that we learned in the previous nugget, and now we can actually look at them and put teeth on them because they're meaningful or more meaningful. So the SSID is simply the name of the wireless. Let me actually stop I'm going to sort by name so it doesn't rotate. So the SSID is the name of the network, and all of these are individual access points, one network per access point. That's why we have so many. Last week, I was in a hotel, and we were close to a condominium, and there were literally more than 40 SSIDs that were showing up as available networks. So here's the list of SSIDs or networks. Here's the channels they're using. Also, I should tell you that on this PC that we're looking at right now, I only have a 2.4 gigahertz card, network interface card being used. So I'm not going to see anything related to 5 gigahertz because I don't have a 5 gigahertz network card currently installed on this computer. So keep that in mind as well. So these are all 2.4 gigahertz related frequencies we're looking at. So there's our channel, and check this one out right here. I've got a lot of people on channel 6, and I've got, looks like Barker is my own network. I'm on channel 11. Maybe I should grade that out. I'm not sure. And I'm using WPA2 personal, which means I'm using WPA2, which is what we're supposed to use, and I'm not using a centralized server, and so I'm using pre-shared keys. There's somebody here, this guy right here, who's using WEP, unfortunately. So that's not good. He's just asking to be attacked. His signal's pretty weak. There's this one here using WPA personal, not WPA2. So we have the whole range right here in my neighborhood. This is actually done from my home office. And in my neighborhood, I've got people running WEP. I've got people running WPA highlighted. I've got people running WPA2 personal. And the only thing I don't have is WPA2 enterprise, which would be in a corporate environment, the preferred method as well. So what else do we know from here? Okay, let's take a look at this. This guy right here is running 2 channels, 3 and 7. Now, those aren't standard channels. We should be running 1, 6, or 11. However, what this person is doing is they're using an 802.11n router with MIMO, multiple in, multiple out. They're doing bonding of a couple channels, 3 and 7, and that's why theoretically they might be able to get 300 megabits per second of throughput. Again, it's all half duplex, so we wouldn't want to run over anybody's toes here. So if we were going to add a new network for our friend in this environment, which is very real world, where would we put it? Well, this down here shows us a graph of the current access points and their strength. So we could say, well, the only person that's really strong close to us is this green line, which is the Barker access point, and he's on channel 11. So we'd want to avoid channel 11 for a new access point because we would be right on top of them, exactly the same frequency range. We'd want to avoid that. So probably almost anything other than channel 11 would be okay. Now, if there's little interference at the edge, we don't care because once the signal goes past our house, outside the walls and so forth, if it starts interfering with somebody else's signal from further down, it's not as critical as if they're right on top of us, signal strength-wise. Check this out. This is also another way to look at it. So here we have in color code, we have the channels they're using. And this also represents graphically what we just learned in the previous nugget. And that is channel 11 is a range. So the Barker SSID here is on channel 11, which basically overlaps from 9 to 13. And we have a whole bunch of people here on 6. And see, this is not good. It's not good for those people, because those people that are currently on 6, they're all duking it out. I mean, if they're close enough that they can all see each other's radio signals, they're having interference, the network is going slow for them, there's lots of retries and everything else, so it's just not good. And there's just a boatload of people in that space. And then we have this D-Link over here on channel 1, and this blue one, which is the DW, right, DBW home net right there, this guy, he's using the bonding of channel 3 and 7, so he's basically taking everything from 1 to 9 because he's overlapping, 3 and 7 using those two channels, which, again, if that signal is really strong, we'd want to avoid it. So this is our planning step. So what would our recommendation be for this? Well, first of all, what type of router do we have? I have a D-Link router. Got it at a garage sale. True story. So I've got a D-Link router. It has not been configured yet. And I'm thinking that we could probably, based on this, I want to avoid 11 because I've got a super strong signal coming from an access point already there. I want to avoid the herd here at 6. I would like to avoid DBW home net because their signal is fairly strong, but there's no way I can. I mean, there's no way I can put this anywhere except for, something that's going to interfere a little bit with DWB home. So there's going to be a little conflict at the edges, but hopefully if I'm closer to my access point than they are to my access point, I'll be okay. So we're going to put it on channel 1. So here we have a D-Link already, and I'm just looking at my network devices because I'm thinking that's not my D-Link. I haven't put one on the network yet. So we're going to add it. So we're going to put them on channel 1. That's our best bet for this customer. And what is the other option? The other option would go buy another wireless router that was supporting the 5 gigahertz band. And then we could pick a clear channel that wouldn't interfere with anybody. But if we have to play in this herd, we're going to play on channel 1. Okay, so that's our site survey. What's our next step? I move this out of the way. So our plan is, let me just jot down our plan so we can make sure we know what it is. Our plan is to go ahead and configure, we're going to use channel 1 in the 2.4 band. And let's also plan on the SSID. Let's call the SSID, let's call it Network Plus, and we'll leave it like that. So it'll be the Network Plus. Also, for security reasons, I'll point this out too, you may not want to give very descriptive names to your access points. And a corporation, maybe it's a different story, but at your home, if your last name is Barker, which mine is, you may not want to label your SSID as Barker, because somebody who's driving around the neighborhood, trying to identify whose access points are whose, it's going to be a lot easier for them to determine. So using a generic SSID, like not D-Link, don't change it from the defaults, but something that maybe doesn't identify you as a person or a home might not be a bad security precaution, is to change it from something obvious. So we'll call it Network Plus. And one other option on the SSID is there's an option on most wireless devices to not advertise it, to not even broadcast an SSID, and that way the user would have to know what the SSID is to join. However, hiding the SSID by not broadcasting it is pretty weak security as well. If there's an attacker who really wants to find out what it is, it'll take him just a matter of moments to do it with his tools. So don't bother hiding your SSID, but go ahead and broadcast it and use a name that is simply not obvious to whose it is. The other thing you can also do is we can do for security, and I'll just leave it at that. For security, we can do MAC filtering. So if you create a MAC filter, media access control, layer 2 address, you can basically say that you make a yes list and a no list. And you can list all the MAC addresses in the yes list that you want to allow clients to connect to your access point, and you can also make a no list, or vice versa. It depends on how the vendor set it up. But that way you can easily control. So you could basically say the people who aren't on the yes list as far as their layer 2 addresses, they are not making it onto my access point. So let's get this D-Link up and running. A couple of things I just want to introduce you to the physical components. There's this physical D-Link router. It looks like this from the back. It's got a couple of antennae, or two antennae. Antenna is singular, antennae I think is plural, and then we have 4 ports. And these 4 ports right here are labeled LAN, and they have numbers on them, 1, 2, 3, 4. And these ports right here, that's just a 4-port switch that happens to be living in the same box as the router and as the access point. It's like 3 things in one: an access point, a router, and a switch all built in together in this little D-Link. Then there's another port over here, and that port happens to be labeled Internet. Sometimes it's labeled WAN because it's connecting off to the bigger internet. And these are all RJ45 connectors. We'd use physical cables to plug into them. There's also a power connector right here that plugs into the wall for power. Actually goes through an adapter. So what I want to do with this is we're going to hit the reset. There's a reset button right here too. I've hit the reset button and I've powered it on, and now I need to go ahead and configure it. So how do we do that? Well, there's a couple of defaults I Googled regarding this router. Number 1, the default username is admin, and there's no password by default. So if we want to log in to manage this box, there's no password for the admin account. Secondly, we need to get physical access or some type of access to this box. So for my PC that we're sitting at, I've got my network interface card, and I've got a physical cable that we're about to plug in to port number 1. Once we plug into port number 1, and if we enable this interface, this D-Link is acting as a DHCP server. And the cool thing about that is it'll automatically hand us an IP address, and it will also tell us what its IP address is by default. So there's going to be a default address. I don't know what it is. But what we can do is we can become a DHCP client, get an IP address, run ipconfig, and it will tell us who the DHCP server is off our local area network, and then we can find out all the details. So I'm going to leave my wireless on. It'll stay on as we do this. So I'll have 2 networks. Now, also, I'm hoping that the network I'm running here, which is 192.168.1.0, that's the network for my wireless. I'm hoping that's not the same network here that's being handed out by this guy, because then my computer will be totally confused on what to do. It's like having 2 streets. Where do I live? What do I do? So it's okay if the 2 streets have different network addresses, but if the 2 networks have the same exact network address, that's a problem. So we'll bring it up and we'll do it ear. We'll play it by ear and we'll see how it goes. So let me bring up my control panel. This is my control panel for the Windows machine that we're looking at right here. And there's my wireless network adapter, and there's my wired one. I'm going to actually, let me enable this. I'm going to enable that interface. And it says, Keith, the network cable's unplugged. I know, I haven't plugged it in yet. I'm going to plug this into physical port number 1 on the D-Link, and hopefully Windows will recognize it as being an active connection, and it should come up and allow it to operate. Okay, well that was without too much fanfare. Let's actually take a look at the command prompt and see what the IP address is that we got. So let's bring over a command prompt. Do you remember the command we can use to verify our IP addresses? What was that? Do you remember? You're saying, Keith, it's ipconfig. You'd be absolutely right. So ipconfig, I've got a lot of interfaces. Well, actually, I don't have that many. I've got several interfaces cooking. But the one we're focused on right here is this guy right here. And this says that the IP address I've been assigned is 192.168.0.199. Now to verify that, we could use what? How do we verify all the details for our IP? ipconfig / all. So the command I just issued was ipconfig / all right here. And that gave me more information, including regarding this interface right here. It shows me who the vendor is, shows me my layer 2 address. Fantastic. DHCP is enabled. Great. It's showing me the IP version 4 address I was assigned, what the mask is, which implies that It's a 24-bit network, and the first 3 octets are the network, and the last octet of my address is my host address. And the default gateway is 192.168.0.1. The DHCP server is 192.168.0.1. And what that really means is the D-Link's address must be 192.168.0.1, because he handed out that information by default to me as I was a DHCP client. So we should be able to open a browser and connect to that specific IP address and have at it. So let me go ahead and pause this for a second, stop that, and let's go to 192.168.0.1. And it looks like I've probably been there before. All right, so this IP address is connecting me through the physical connection to the D-Link to its management interface. The default username is admin, and there's no password, so we can click on login. And then it's got a setup wizard that I can do for connecting to the internet. And it's got a manual internet connection setting. For wireless, which is what we want to focus on here, let's go ahead and run the manual. And I'm not really too concerned about you memorizing the actual interface and where to go, but it's more important the concepts of setting up the wireless. So our goal is simple. You and I want to set up the channel 1 at 2.4 gigahertz band for just channel 1, and we want to change the SSID. So we'll do manual wireless network setup, and it's enabled by default, which is great. We'll change the name Network Plus based on our plan, and it's asking us what mode we want to be in. And this little guy will do 802.11n, G, and B. So we could say, you know what, let's just do G. So for our purposes, that'll be great. And then this option right here, enable auto channel scan, is really handy because you know what? Things change. If we forced it to channel 1, which we're about to, and then later one of our neighbors also set up channel 1, there would be a conflict there, and we might interfere with each other's signals if we're close enough. So auto channel scan will have your access point, if it's supported, as a feature like this is, it'll go ahead and see if there's congestion or if that channel's in use by other people, and it can actually switch dynamically to a different channel, which is pretty cool. So we're going to force it because that was our plan. So I'm going to go to the channel 1, and of course channel 1 overlaps with channels 2 and 3. So we want to use channel 1 or channel 6 or channel 11 in the US for the 3 channels that have no overlap with the other channels, the other one between 1, 6, and 11. All right, so let's use channel 1, and the transmission rate, we can say that's automatic. Do you want to advertise the SSID, yes or no? Invisible says no. Visible says yes. And then, do you want to have security? And the default is no. We do want to have security, so let's go ahead and use WPA Personal, because we don't have a back-end Radius server here, but we can use WPA. And then once we say we want to use WPA, it explains the difference between WPA and WPA2, and we'll use WPA2. Oh, look at that. So we can use WPA or WPA2. We can support both types of clients. Let's go WPA2, and let's just go ahead and use WOW. And we can use TKIP and AES. So I'm going to say AES. So typically, we have CCMP and AES that work together for data integrity and for encryption. We'll say AES for cipher, and then we'll go ahead and we'll still say a pre-shared key of Network Plus. All right, so an alphanumeric phrase, at least 8 characters, Network Plus, NETWORK plus. That'll do it. That's 8 characters. And we'll click on save. So now that we've configured the wireless portion of this wireless router, what do we do next? Well, the next thing would be to go ahead and associate or connect to it. And the way we can do that is from the client. So from my PC, if I click on the icon for my network and I want to join a new network, it's going to show me a list of all the networks that are there. So you can see right here, there's the Network Plus. Signal's really strong. I can click on that. And when I click on that and I click on connect, it's going to say, what is the security key? Now this is the pre-shared key that we set up, which was Network Plus. Now it just so happens to be that that's what we used as the SSID, uppercase Network Plus, and we also used Network Plus for the key, which probably wasn't a great idea. I should make that maybe a little more challenging. and then click OK, and it should associate. So right now we're associating with the D-Link, and we're getting an IP address from the D-Link. So just as a heads up, what we just did was the PC was right here. There's the happy computer. We had wired into the D-Link. It had assigned us an IP address via DHCP on the 192.168.0.0 network. And we were also connected wirelessly to a different network. But now when we just associated with the D-Link again here, it now again handed us another address of 192.168.0 something on our wireless. And now my computer is not in a happy state, because if this computer has two IP addresses or tries to have two IP addresses on the same street, the same network, which one is it going to use? How is it going to sort it all out? It's not the typical fare for a Windows computer. Now servers, they might be able to use multiple interfaces and do network interface teaming and so forth, but end user devices aren't so good at it. So what we could do is we could disconnect the physical connection and just use the wireless as we now operate on this wireless network. So let's do a quick test and verify that everything we intended to do was done in this configuration. Number one, we intended to configure the SSID to say Network Plus, and there it is. So this is the SSID right now, real time, that's being advertised. Great. We intended to use channel 1. That's fantastic. And we intended to use, well, actually, we didn't intend to use it, but as good policy, we used WPA2 personal version with pre-shared keys, and it's showing us that that's currently what is in use. It knows based on the MAC address of the Network Plus device that it is a D-Link based on the first 6 characters of its layer 2 address, and we are in infrastructure mode. So we're not doing ad hoc. Infrastructure is where you have at least one access point as the glue for all your wireless clients who want to go ahead and communicate. And this last piece here about the maximum rate, that would be if we were using N, 802.11n, and doing the channel bonding to get that 300 megabits per second of throughput. So what have we covered in this nugget? 2 basic items. Number 1, our goal was to plan the network, which we did. And the second was to go ahead and configure it. Not only did we configure it together, you and I, we also verified it by getting a client associated with our brand new access point. I hope this has been informative for you, and I'd like to thank you for viewing.